Welcome back, folks. Today we're going to be talking about an extension of what we were doing the last couple of days. We're going to be talking about applications of systems of equations. Applications of systems of equations. Now, for applications of systems, we're allowed to use any of the three methods that we want. We covered three of them. So let's refresh ourselves on what those three methods are and when we may want to use each of these. Go ahead and do that, and then I'll put in what I would say. So our three methods were graphing, we had substitution, and we had elimination. Now, when would we use graphing? When we already had things in y is equal to mx plus b form, or if everything looks pretty simple. If it looks simple and graphable. So meaning that we don't have things like 13x, or we don't have fractions or decimals. What about substitution? When would we want to use that? When we have a coefficient for one of our variables equal to 1. So when we have a variable by itself, if the variable is by itself, then we don't have to do any of the work to substitute, we just have to put that into the other equation. Or if we have a coefficient that's 1, then we just have to subtract to get it so that we can substitute. And what about elimination? Well, if we already have two coefficients that are equal and opposite, that'll help. Or if it's just one of the two, if it's equal or opposite, and we can multiply to make our lives easier. So keep this in mind as you're doing these problems. I'll be using whatever method makes the most sense in my head, but you can use whatever method makes the most sense for you. And today we're going to talk about real-world applications. The first one is sort of the first type of problem that I like to deal with, or the first type of problem that I think we have. We have 13 coins, both dimes and nickels, and we have a total amount of money. We're looking for how many dimes and how many nickels we have. It's pretty clear here that our two unknowns are dimes and nickels. So those are going to be our two variables. What two equations do we have? Well, we know we have 13 coins overall, and that's only dimes and nickels. So our number of dimes plus our number of nickels will be equal to 13. And what about the other part? Well, we have a total amount of money. Let's convert this into cents. We know we have 110 cents total. And we know that dimes are worth 10 cents each, and nickels are worth 5 cents each. So this is the first type of problem, where we'll have some sort of combination of two different types of things, like dimes and nickels, apples, oranges, anything like that. And then each of those has some sort of value linked to it. It could be something like cents, something like coin, or it could be anything else. Now, how would we solve this? I'm looking at this and I'm seeing we have d and n by themselves here. So what I'm thinking is that we probably want to solve this by substitution. Let's subtract d, we'll get n by itself. We get n is equal to 13 minus d. And we can substitute in 13 minus d for n in this equation. This becomes 10d plus 5 times 13 minus d is equal to 110. Let's finish doing the math out here. Let's see what we get. We get 10d, 5 times 13 is going to be 65. So this is going to be 10d plus 65 minus 5d is equal to 110. And then when we go ahead and solve this, what will we get? Let's see, subtract 65 from 110. Then we're going to need to divide by 5. We'll find out that our number of dimes is 9. So we know our number of dimes is 9, and that's really handy because we know our number of nickels is whatever we have left over. So our nickels will be equal to 13 minus our 9 dimes, and our nickels will be, let's see, what will that be? 4 nickels. Now how do we check and make sure this works? Do we have 13 coins total? We do, we have 9 and 4. And will these add up to $1.10 or 110 cents? Well, we have 90 cents plus 4 nickels will give us 20 cents. So that works out. This is our first type of problem, where we add together a total number, then we have some quality that we add together. Why don't you go ahead and try this for problem 2? We'll figure out what our solution is. For problem 2, our variables are going to be chickens, and our second one is going to be our number of sheep. Now we know that our total number of chickens and our total number of sheep will be 17. We have 17 animals that went through, and how many legs do chickens have? They have 2 legs each, and each sheep has 4 legs. Altogether, there were 60 legs that went by. Again, we're looking at this. I think substitution is probably the best way to do this because we have C and S by themselves. So let's go ahead and solve for C. We get C is equal to 17 minus S. When we substitute that back in, we get 2 times 17 minus S plus 4S is equal to 60. When we simplify that, that should come out to, let's see, 17 times 2. So that'll be 34 plus 2S is equal to 60. Or we'll find out that our number of sheep will be 13. Find out that we have 13 sheep. And again, this makes our life simple because our number of chickens will just be 17 minus 13. Our number of chickens will be 17 minus our number of sheep. So we'll have 4 chickens and 13 sheep. Now, does this work out? We have a total of 17 animals, so that works. And do our number of legs work out? We have 4 times 13, so that's our number of legs from sheep. We have 52 legs from our sheep, and we have 8 from our chickens. So it does work out to be 60. Right, let's move on to another type of problem. We have 2 candles now. One is 10 inches tall and burns at a rate of 0.75 inches an hour, and the other 6 but only burns at a rate of 0.25 inches per hour. How long will it take for them to reach the same height, and how tall will they be? So this one is a little bit more confusing. For this one, we need to figure out what our variables are. We have per hours, we have something changing with time, so let's make t one of our variables for time. Now, what is changing with time? Looks like these candles are getting shorter, so our height will be changing. And now let's try to create our equations. For these types of problems, we'll have one equation for each different type of thing. So we'll have one equation for the first candle and one equation for the second candle. For the first candle, our height will be equal to, well, it starts out at 10 inches tall, and we lose 0.75 inches an hour. So 0.57 inches per time. And we'll say our time is in hours. For the second, so this is the first candle, the second candle will start with a height of 6 inches, but we'll lose 0.25 inches per hour. Right. Now looking at this, again, substitution might be the best way to go. We could graph these, or we could do substitution because we have 2 different variables for h. We can just set each of these equations equal to each other. So we see that we have 6 minus 0.25 t will be equal to 10 minus 0.75 t. Once we get everything to all of our different sides, we'll end up with 0.5t on this side from adding, and when we subtract 6 over, we'll get 0.5t is equal to 4. Throw that into our calculators. We'll find out that our time will be 8 hours. Now, how do we see what height they'll be? We just substitute in 8 for t in either one of these equations because we know they'll be the same. Let's use the bottom equation. It looks like our numbers will be slightly less. So we get h will be equal to 6 minus 0.25 times 8, or this will be equal to 6 minus, let's see, 8 times 1/4 will be 2. So our height will be 4 inches. Now we have to make sure that this works out. Will both our heights be 4 inches at a time of 8? So looking at this, we know for the first equation it'll be 4 inches, or the second one. If we put it into the other equation, we'll have to check that. What is 10 minus 0.75 times 8? That also gives us 4 inches. So we know that this is correct. All right, your guys' turn to try another problem. This time, we're renting movies. You can pay a flat $20 membership fee, and then you only pay $1.50 per movie, or you pay $2.10 per movie. We want to figure out how much it'll cost us and when these two will be beneficial. So what will our answers be? Looking at these, it's clear that what's changing is our cost. So that's what's going to be changing. And what is the cost changing based off? It's changing based off our number of movies we rent. So with our first option, the cost is going to be equal to $20 plus $1.50 per movie. For the other one, for the second one, we have no memberships fee, so there's no flat fee, but it costs $2.10 per movie. Again, looks like substitution is going to be the easiest way to do this. So we'll substitute in 2.10 m for c in this equation. So we get 2.10 m is equal to 20 minus or plus 1.5 m. Let's subtract the 1.5 m from this side. We'll be left with 0.6 m is equal to 20. Or when we divide that through, we'll find that this will make sense at 33.3 repeating movies. So for a real answer, right, we're not going to buy that much. It'll only make sense to do after 34 movies. But we'll come back to that because we still need to figure out what the cost will be. And how are we going to do that? Well, we can just substitute this in for either one of our equations for m. The bottom equation looks like it's less work, so let's plug it in there. C is equal to 2.10 times 33.3 repeating. And what does that come out to be? The cost will be $70 before it comes out even. So this is our actual answer, is m is equal to 33.3 and c is equal to 70. However, if we're trying to be realistic here, we can't rent a third of a movie. So we'll go up to 34, and what will our cost be then? We'll substitute in 34, and when we substitute in 34, we find out that it'll be $71.40 before it makes sense to buy the movie pass or the premium subscription, whatever that happens to be. All right, we have one more type of problem. These are definitely the most confusing, so we're going to draw a picture for these. We have two kayakers who are paddling in a river. Both are paddling at the same speed, but one is moving upstream and the other is moving downstream. Therefore, one is going faster relative to the shore. If one is moving 9 miles an hour and the other is moving 3 miles per hour relative to the shore, then what speed are they paddling and what is the speed of the current? So this one's a little bit more confusing. Let's try to draw out a picture here. We have some sort of river here, and the river is going to have a current on it, right? It'll be pushing this way. We're going to have one kayaker who is trying to make their way upstream. So they're trying to work their way against this. Let's put these kayakers in a different color. We have one kayaker who's trying to go the other way. They're going against the stream. And how fast are they going? Well, they're going against it, so it'll probably be slower. I think we're safe to say that this will be 3 miles per hour. Meanwhile, we have the smarter kayaker. They've decided to just go with the river, so they're flowing with the river, and they're moving 9 miles per hour. And this gives us an indication of what we have to do. One has a speed. These are both going the same speed. They're both paddling at the same speed. But we know one is working with the current and one is working against. So how are we going to approach this? Well, we don't know the speed that they're paddling, nor do we know the speed of the river. Let's make those our variables. So we'll call P our paddle speed. And we'll call C our current speed. But what do we know? Well, we know that the one who is paddling and gets the benefit of the current, their speed is 9 miles per hour. Right? So they're going downstream, they get the paddle, plus they get the extra speed. But the other person, they're losing speed to the current. They're working against it, and they're slowing down. Their speed is 3 miles per hour. So this is another type of problem you can see, where we're adding two things together, and then we're subtracting. We're making a difference, and we know what the difference is between the two. This is another common type of problem that'll show up. Typically, if we have current speed, if we have wind speed, anything like that. From here, what does it make sense to do? Well, C is already equal and opposite in each of these, so I like elimination. Let's go ahead and just add these two across to find 2P is going to be equal to 12 miles per hour, or that our paddling speed will be 6 miles per hour. What about for the current? Well, the current is going to be P plus C is 9, so 6 plus our current speed is 9 miles per hour, or our current speed will be 3 miles per hour. So here are our two answers. Current speed is 3 miles per hour, and our paddle speed is 6 miles per hour. And folks, there you have it. That's a couple of different applications that you can see. Go ahead and try these on the homework.